Good morning, flash flood experts. Thank you very much for coming to this important session. Just a quick recap. In the previous two sessions, we covered how to prepare the input static layers and also how to prepare the input dynamic layers. So this is what we did during training 7 and also during training 8. In this session today, we are going to cover how to do the sensitivity analysis. And the sensitivity analysis, it is very important to know the sensitive parameter. And those sensitive parameters, those are the parameters that we are going to use during the calibration. Because during the calibration, we need to know, for example, which parameter is connected with recession, which parameter is connected with the peak, which parameter connected with the attenuation, for example. So to understand these important things, we do that through the sensitivity analysis. And in this assignment, we are going to explore and to do together this sensitivity analysis. And most parameters in this Wflow are based on available data set. And the important parameter, for example, K sat horizontal fraction. This is the ratio of horizontal and vertical hydraulic conductivity, and it can range between 1 to few thousand and has large influence on how fast water flows in the subsurface. So this is one of the sensitive parameters we are going to use in this assignment. Also, there are other important parameters, for example, N. This is the Manning roughness. So this is the roughness parameter. And also we have the soil thickness, or we can call it maybe the soil depth. So this is also one of the key parameters. We also have F. This is like a scaling parameter for the decline of the vertical hydraulic conductivity. We also have KV underscore 0. This is the vertical hydraulic conductivity. And this parameter, the vertical hydraulic conductivity, it controls how fast the water infiltrate into the surface. So this is also one of the important parameters. So you can start test these parameters in this assignment for today. But still, if you are interested to test more other parameters, still it is good also. And here, this is the documentation page to describe these parameters. And here, for example, if we want to change this parameter, we can change, for example, we can start by changing this parameter. But before we change this parameter, we need first to extract the original data, or the original flows, or the baseline. We can call it the baseline flows before we change, because here we want to see how is this parameter affecting the flows at different points. So the first thing we need to do is to get the original or the baseline flows. And then after we change this parameter, we want to see how the flows changes. So this is very important. So the first thing, we will go to our working directory, and we go to Wflow, and here we go to this file, for example, our folder, I mean, and then we need to open this output this output without changing any parameter. So we need to open this first. Maybe we can use Excel. Okay, if we go to data, depending on the Excel and the version that you have, you may use another way to open, but for this version, so here I'm opening now. Okay, Wflow here, and this is the output. I import. Yes, I load. So first of all, I need to copy this. These are the flows with the time step that I have. I need to copy this first outside. And then after copying that, for example, at this location 1, Q1, or Q7, or Q4, or 2, or 5, or 6, or 3, after I copy these ones, I can then after that, when I do the sensitivity analysis and I change one of the parameters, I can compare these two different flows. Like for example, Q1 here and Q1 again after I change the parameter. So this is very important. Now after that, we can go to our TOML file, and then, for example, we can change this parameter. And here, for example, we can set it to 500. So if we go back here, okay, so this is our file. This is the TOML file, or we can call it like the master file. All the parameters, they are here. So this is the original. Originally, it was like that. And this one, it was not there. But what we did, we commented this one here, like this. And here, we put the value for this parameter, the KS here. We put it like 500. And then we save. And then we run our model, same like we used to run in the past. So after running the model, we are going to extract. Here, as you see, we extracted first the baseline values. And then after that, after we change this parameter, we extracted the values again. And then we can compare both of them, like compare Q1 here with the baseline with Q1 here after changing this parameter, or comparing, for example, Q4 or Q6 or Q5. We can compare these parameters. This is very important. Now, if we want to do another sensitivity analysis for another parameter, we need to make sure that we put back the value for this case. We cannot do sensitivity for 2 parameters or 3 parameters on the same time. If we change one of the parameters, we need to put it back. And then after that, we can do sensitivity analysis for other parameters. Like here, for example, this is how to do like the sensitivity analysis for the Manning roughness. And here we have like overland, and we have river. So if we want to change the river one, for example, this is how to do it and to give the value. This is also for KV. We can also do the sensitivity analysis, but we need to make sure in the previous one, we put back the value to the original value, and then we do a sensitivity for another parameter. So this is how you can do the sensitivity analysis. You can test different parameters, and to have that understanding how these parameters affect our hydrograph. Is it affecting the peak? Is it affecting the recession? Is it affecting the attenuation? Is it delaying the flow? Is it accelerating? So to have that understanding, we need to do it through this sensitivity analysis. Allow me to thank you again for your active participation and also attend this important session. And thank you very much and have a nice weekend. Thank you.